All right, let's take all these pedigree skills that we've been learning, combine them with our probability skills, and we're going to make it harder because we're taking a sex-linked recessive trait and we're talking about probability. I want to know the probability of each of these parental couplings causing an affected offspring. Well, we know it's sex-linked, so this father, right, who's affected, could not have passed on the affected allele to this father, right? He's unaffected, right? There's no way he could pass this allele on, right? We assume someone mating him from the outside is homozygous unaffected, so the probability of having an affected child is 0 here. Now let's come over here to the right and do the same thing. We have an affected father. You might think, oh gosh, well that means he has a higher probability of passing it on and having an affected child. Well, if he has an affected X, he's only going to pass his Y on to a son, so the son can't be affected. And if he passes it on to his daughter, the daughter is not going to be affected because she'll be heterozygous, right? Because this mating in from the outside, we assume to be homozygous unaffected. So she may carry the allele, but she'll be unaffected. So again, 0 probability. But now let's take the middle scenario. The father must have passed on this allele to his daughter. So we have X plus and X minus, heterozygous here. We are going to assume homozygous unaffected, so X plus Y. These are definite probabilities, 1 and 1. If they have a daughter, the father's got to pass on 1 X, and it's going to be unaffected allele. And the mom can pass on either or, right, plus or minus, and it won't matter because she has 1 good copy from dad, so she's not going to be affected. But then we have the case of a male. If they have a son, well, dad's going to give down a Y, but mom could give either the X with the unaffected allele or the X with the affected allele. And if she gives the X with the affected allele, then we're going to have an affected individual. So you have to combine the probability that mom can pass on the affected X, which is 1/2, and the probability that they're going to have a boy, or the probability that dad's going to pass down the Y, which is another 1/2. And 1/2 times 1/2 is equal to 1/4, or 25%. And that would be the answer to this middle question here.